I will explain about introduction. High Performance Liquid Chromatography (HPLC) is a process of separating components in a liquid mixture. The liquid sample is injected into a stream of solvent, mobile phase flowing through a column packed with a separation medium, stationary phase. Sample components separate from one another by a process of differentiation migrations as they flow through the column. Objective: There are three objectives of HPLC: to separate the constituent of compound, tell how much of each component is found within the mixture, and helps to identify what each compound is. Secondly, to identify, quantify, and purify a compound or analyte. Thirdly, to allow qualitative and quantitative analysis of what components and how much of each component are contained in the sample.
Moving on to the methodology, here is the schematic diagram of HPLC. First, we have the mobile phase in the solvent reservoir. Next, the pump delivers the mobile phase through the system. Then, the liquid sample is injected into the column where separation of components occurs. Finally, the separated components pass through the detector, which converts them into electrical signals for analysis.
Moving on to the next part, which is specific name and function. First, solvent reservoir. The function of solvent reservoir is to store the mobile phase or solvent used in the HPLC system. Second, we have pump. The function of pump is to force the mobile phase to flow through the packing, also to maintain stable flow and to avoid possession. Third, we have injectors. The function of injectors is to put sample in the mobile phase. Next is column. The function of column is to separate the sample based on their interaction with stationary phase. There are two types of column. The first type is analytical column and the second type is guard column. The function of guard column is to increase the lifetime of analytical column. Last point, we have detectors. The function of detectors is to measure the concentration of the analyte as it elutes from the column and passes through the detector cell.
Then HPLC setting. The HPLC system used in this study was a Shimadzu Corporation model 1514 equipped with a Zorba Eclipse Plus C80 column. The column had a pore size of 5 micrometer, an internal diameter of 4.6 nanometer, and a length of 150 millimeter. The analysis was performed in reverse phase mode using ODS. The flow rate was maintained at a constant 1 mm per minute with the column temperature set to 40 degrees Celsius. Detection was carried out using a UV detector set at 275 nanometer. The mobile phase consisted of HPLC grade water and methanol in a 60 to 40 ratio. A sample injection volume of 10 microliter was used for each analysis.
Next is result and discussion. First one is chromatogram graph of caffeine at 2 ppm. This chromatogram shows the peak for caffeine at a concentration of 2 ppm parts per million with the detector set at a wavelength of 275 nanometer. The peak is observed around 2.6 minutes retention time, which helps confirm the identification of caffeine based on retention time and absorbance. Second one is chromatogram graph of caffeine in a T sample. This chromatogram represents the caffeine content detected in a T sample with similar conditions detected at 275 nanometer. The retention time of caffeine in the T sample, approximately 2.6 minutes, matches the retention time of the standard. This confirms the presence of caffeine in the T sample. Last one, the calibration curve. This graph displays the calibration curve for caffeine quantification. It plots the area under the curve against different caffeine concentrations. The high correlation coefficient demonstrates strong linearity in the range of 2 to 10 ppm, indicating the method's reliability for caffeine quantification.
Next, limit of detection was found in this experiment is 0.2 ppm, while limit of qualification is 0.7 ppm. For table 1, intraday precision, percent RST for detection time was 0.903% at 2.648 minutes. The peak area was 1.14%. For table 2, intraday precision, percent RST for detection time was 1.635% at 2.690 minutes. The peak area was 1.48%. The recovery are all within a tight range, which is from 97.6% to 98.8%. The T sample contained in this experiment is 2.5% to 3.5% caffeine, while coffee sample contain 1.17% to 1.34% caffeine.
Conclusion: HPLC is a precise and accurate method for qualitative and quantitative analysis. Secondly, there are many opportunities for developing new HPLC methods such as within non-stationary and mobile phases. Lastly, HPLC can be used to analyze drugs, polluted and food components and explosive residues.